Today we can discuss about the paper chromatography. In the previous classes, we had to discuss about the general chromatographic techniques, whatever the RF values, and there are two different phases: mobile phases, stationary phase, etc. We can already discuss about the chromatography technique. Today we can discuss about the paper chromatography. How the paper chromatography is introduced in the global. The paper chromatography was first introduced by Cobian in 1865 under the name of capillary analysis in 1944. In previously we have to take the paper chromatography, we have to call it as the capillary analysis in 1944. After 1944, we have to call it as the paper chromatography. This is the introduced part. PC is considered, paper chromatography is considered to be the very simplest technique and most widely used in the chromatographic techniques. So, for different types of chromatographic techniques, this is the mostly very simple and most widely used for the chromatography. It is because its applicability is also most important because the any components we have to take easily isolation, identification, and quantitative determination of the low molecular weight of the organic and many inorganic compounds. Not only for the organic compounds, in many inorganic elements, just like our trace elements are present in any sample, we have to determination like quantitative determination for the very low molecular weight, that is the uh, very click model, that is the paper chromatography in the global. And the paper chromatography can be divided into two categories. Another one is the paper partition chromatography. Paper partition chromatography. In paper partition chromatography technique, the filter paper acts as an inert support. That is called inert support to which the solvent, usually water present in the cellulose of the filter paper, acts as a stationary phase, and the other solvent is the organic solvents acts as mobile phase. We have to have about that. What is the use of what is the paper chromatography? Paper is not ordinary paper, not ordinary paper. Every paper manufactured or paper contains the cellulose layers, no doubt at all. In paper chromatography, specially made from this technique, cellulose layers are there. But in each and every cellulose layers of that in that paper contains the small, tiny water particles are there. Water present, H2O molecules, H2O molecules are present in that filter paper. That filter paper means cellulose of the filter paper. That acts as a stationary phase. What is the stationary phase in the paper chromatography? Stationary phase paper chromatography means water is present in the cellulose of the filter paper. That only you have to call it as the stationary phase in the paper chromatography. And the other one is the two phase. Second phase is the solvent. In all general technique, you have to call as the solvent. Maybe in organic solvent, it acts as a mobile phase. It acts as a mobile phase. Thus, the substance mixture move the two non-mixing solvents, create the partition between them. Two non-mixing. Is there a mixing? That is useless thing. But is the non-mixing solvents that is different to create the partition between the two solutions. We had already mentioned the partition chromatography. That is a paper. In the paper chromatography, what is the stationary phase? Stationary phase contains the stationary phase means in paper specially made paper from to the paper chromatography. That cellulose layer contains the water. That is the stationary phase. Mobile phase is the solvent. Another one is the classification. Is the second one is the we have to called it as the APC. That is called adsorption paper chromatography. Adsorption paper chromatography. In APC filter paper immigrated, same just like that in the previous mentioned adsorbents such as the alumina or silica and a single solvent used allowed to flow the unknown components. In the adsorption chromatography, only single solvent is used. Some paper chromatographies are the two different solvents are used, maybe. That's why we have to use the mentioned that single solvent is used, that is in the adsorption paper chromatography. Some of the components may be adsorbed more strongly than other, causing the variation in the amount of the substance which tends to the flow of the solvent. This facilitates the separation of the components. So separation of the components. So in APC, the filter paper, the single solvent, we have to adsorbent is also most important. That is called the alumina or silica gel. So alumina or it is called APC. This method, partition chromatography, the filter paper strips carry their inert support. The factors governing the separation of the mixer solution on filter paper, that is called partition between the two immiscible phases. We have to most important partition is the two immiscible phases. That immiscible phases, that is not useless thing. Another one is usually water adsorbed on cellulose fibers. Water is always adsorbed on cellulose fibers in the paper, that is called the stationary phase. We are already I am already mentioned about that stationary phase in the paper chromatography. Cellulose fibers in the paper, that is called the stationary phase. That is contain water. Water adsorbed on cellulose fiber, not cellulose fibers. Please remember that stationary phase, not cellulose fibers. Water adsorbed on cellulose fiber acts as a stationary phase. Another one is the second is the organic solvent flows past sample on the paper. On the paper, you have to move from top to sorry from bottom to top or left to right or right to left from top to bottom. That is called the immobile phase. We have to mention about that one. We have to see the paper chromatography. This is called mixer. We have to take the red balls. Three balls are there, and triangles. Three triangles are there, and another one is the four green balls are there, and two yellow balls are there. We have to different shapes, different molecular weights of the components present in mixer. Then we have to apply the paper chromatography. Then we have to separate by using this technique. Red balls are separated, low molecular weight of the green are separated, and blue are component separated, and the yellow are component. One, two, three, four. Four different components are separated in your given mixer, and then we have to quantify how much quantity is present in that separation in the red balls, how much quantity is present in the green balls, how much quantity is in the triangular shape of the substance, how much quantity of the circular yellow components are present in the separation mixer. This is the technique of the paper chromatography. All the different shapes. This picture shows that different shapes, different molecular weight of the substance, different quantities of the substance. We have to separate and identification of the components by using the paper chromatography. It is also what is the use of paper chromatography? That is used for the ink analysis, forensic analysis, and pharmaceuticals and dyes and pigments, food coloring substances. And food coloring plant constraints is for the ink analysis. Is there a different ink analysis that is called the blue, red, black, whatever it may be? We have to separate it and how much quantity is present in that particular analysis. And the forensic analysis nowadays are the most important for the, is there any murder or any other civil, in the civil area? We have to give the forensic analysis a greater vital role by using the chromatography technique by paper chromatography. In the pharmaceuticals, I already mentioned about in the previous classes, pharmaceuticals in the drugs and raw materials, whatever it may, the pharmaceuticals, drugs are present in the binding agents and other ingredients in your manufacturing units. You have to use this paper chromatography technique and dyes and pigments and coloring of the compound, paints and whatever it the color components, pigments, natural pigments and unnatural pigments. We have to using this technique. We have to mention. And the another one is the food coloring. That is the nowadays are most important. We have to take for the outside of the food. We have to contain the lot of food contains the different colors. The customers attracting the different colors: brown, red, orange, grape. Just like those colors, we have to attracting the mm, color sprayed food. How much quantity of the color present in that particular food? You have to calculate, we have to identifying that component, that is maybe synthetic colors, maybe the food colors, how much quantity is present, is there any harmful in that food color in the living system. We have to analyzing that color by using this technique, that is the most useful nowadays. Are, is there any food poisoning, how the poisoning in the way of that food in the human beings. So we have to calculate it that toxic materials present in that particular food contents in the outside of the food, that is called the street food. And the plant constituency, another one is the plant constituency. In that plant extract, how much kind of chlorophyll contains, is there any pigments, whatever it may be the in the plant, we have to mention about that. All these parameters we have to use that paper chromatography. Suppose you have to take that, this is called the chamber. This is called the external. This is called the upper part of that lid. This is called the glass rod, and the one clip is there. This is called the paper. This is called the paper. The solvent front. This is called the solvent. You know, is the basic one. You have to draw the baseline separation of the all the parameters. You have to use that paper technique. These two are not same. These two are not the same. These two are not the same. Different components. This is the light color. This is the dark. Maybe some slight difference. Maybe components in the given mixture you have to already separated by using this technique in the paper chromatography. We to see, we have to take already mentioned about that one activity. We have to take the mention. You have to you see that one ink spots. This is called green color. This is also green color just like up here, but small difference is between these two spots. This is also two blue colors they are appearing, but these are the slight difference between these two colors. These are also similar colors, but these are also little bit difference in between these two colors. In the solvent front side, you are using that paper chromatography. Slight difference or low molecular weight, similar, almost similar molecular weight substances. Maybe definitely we have to resolve the all the components. How much quantity is present in the particular sample, that is the great technique by using this paper chromatography. Another one is the partition. How the paper chromatography works means, there is a partition between the mobile phase and the stationary aqueous phase bound by the cellulose. Already mentioned that stationary phase, what is meant by stationary phase? In the stationary phase contains the paper, water is present in the your cellulose layers, that acts as a stationary phase. That's why aqueous phase. Aqueous means water. That water phase bounded by the cellulose layer. And another one is the isolation. The isolation means separation. That is also depends upon the partition coefficient of the solute. Isolation means it depends on partition. The partition coefficient of the solute. K is equal to C, that is called stationary phase, C by mobile phase. This is the partition coefficient, isolation of the depends. But what is the mentioned about that one? How to, what is the general procedure for that one? We are using the choice of the filter paper, and solvent is used, and desalting of the sample, application of the sample, equilibration of the paper, and development of the paper, and detection, identification of the substance. All the 7 parameters by using the general procedure for the paper chromatography. You see the example, the basic line we have to color to different components. We have to take these spots, just like this is one example. In the migration rates, RF value, you are in the previous classes we have to mention about that RF value means a retardation factor, retention factor value. The distance traveled by the relative to the solvent is called the RF value. Relative to the solvents, that is called, one formula is there. RF, distance traveled by the compound by distance traveled by the solvent, that is equal to the, it is always already mentioned that RF value is always less than 1, less than 1. That is the most important for the calculation of the RF value. Is there any your RF value is greater than 1? That is quite absolutely wrong. That is before below the RF below the 1, that is quite absolutely right. That is the similar values concluded that in the same component. What are the, is there any effective of the RF value? Yes, definitely affecting the RF value. Type of paper. Suppose we have to not use any quality of the filter paper, quality of the paper, that is effect adverse effect on the RF values. We can RF values may be different type of paper. And the solvent composition, we have to use the composition of the solvent is most important for the paper chromatography. Similar solvents and aggregation of the sample solvent and 100% of the solvent used, then only you got the good RF values. And the temperature, we have to mention about the temperature. Temperature is the most important for that one. We have to take the room temperature only, not more less the minus 10 temperatures and more than 30 degrees centigrade. Definitely the RF value may vary. That's why it not calculated the accurate value. And the another one is the chamber saturation. Chamber saturation means we have to take the apparatus of the chamber is always moderate, and solvent vapor, that is called mobile vapors, are the always saturation. That is the most will affect the RF value. Is there any will not affect the RF value? Yes, that is also most important. You have to take the solvent volume. Solvent you can take the 3 ml, 10 ml, 100 ml, 250 ml. That is not a matter of fact. That is not affecting the RF value. And size of the paper, you have to take the size of the paper means you have to take the 10 centimeters or 1 meter or 2 meters, whatever it may be the size of the paper. That is not any effect of the RF value. And the sample size, you have to take the sample very micro quantity. You have to take the macro quantity of this sample size. That is also did not affect any RF value. That is the only factors affecting the type of filter paper, solvent composition, temperature, and chamber saturation. That is only affecting the factors affecting the RF values. So, what are the techniques of the development of various flow directions? Is there different types of radial development, ascending technique, and descending technique is the two. We have to mention about the ascending technique, ascending paper chromatography. Ascending paper chromatography. We have to take that filter paper, paper ascending technique 1, 2, 3. This is called the baseline. Baseline 1, 2, 3, 4 sample size, clip wire, and this is called the solvent. In that chamber, we have to take ascending means from bottom to top. Definitely we have to descending paper technique. Descending means from top to bottom. In the these are the called spots 1, 2, 3, 4, 5. This is called baseline. In the spots we have to solvent vapors. We have to take the paper suspended through anti siphon rod. This is called anti siphon. Separating edge allowed to. We have to take the spots are there. We have to calculate it in the RF values, and in this descending technique, definitely we have to calculate the RF value. We have to mention about the this one. And another one is the radial paper chromatography. Circular phase is there. This is called the sample. This is called the wick. Circular phases. One is the 1, 2, 3, 4, 5, 6. That is calculated the RF value. We have to RF value and how much quantity is present in that solute present in your sample. You have to. These are the three techniques. One is called ascending technique. Another one is the descending technique, and radial paper chromatography. These are the one part of the paper chromatography. That is the in paper chromatography is the most important versatile technique. This is the some part of the paper chromatography.